Of digital cultures and lighthouse professor, whatever that is. And I'm a historian of science by training, but I also do a lot of ethnography and work on a lot of things like smartness. And today I gave you two readings. One of them was about a very short essay by a famous philosopher titled Gilles Deleuze on the postscript to the Society of Control. And the second was a short essay I'd written about concerning the idea of versioning and prototyping and the way we build and engineer and design computers today, and its relationship to politics. And today that's going to be one of the things we're going to ask ourselves. So since people tell me they don't really actually know that much about these histories, I'm going to situate. I know my class has gotten a little bit on cybernetics. Most of this will not be about cybernetics, worry not. But I'm going to, and I'm sure you can, who can't use a little bit of a repeat, but I'm going to give you kind of an intro to my work, where the question of demos and prototyping comes, and mostly we're going to do a history of artificial intelligence and what is often titled ubiquitous computing or big data infrastructures. So how have we come to see ourselves? I always love to flash around things like my objects as immersed in media all the time, right? So you know, maybe you don't think about it, but I always tell my class this, right? But like, what's the first thing you do in the morning? Grab your phone and check things. Maybe not you, but I do. So one of the questions is, we take that as kind of natural, right? That we're always checking our phones and getting online and looking at all this stuff. But actually, there's some serious questions we should be asking about how we've come to what we call naturalize. No problem. Hey, Claire, how are you? How we've come to naturalize this situation. So I think a really interesting place to start is with this quotation by Nicholas Negroponte, who is the former, how many of you have heard of the Media Lab at MIT? All right, cool. No one. So basically the Media Lab is one of the one supposedly considered, and we can question this history, and in fact one thing you should be asking me about is my methods, is my history, because as master's students, one of the things we have to think about is the stories we tell and the histories we build about computing are going to have a big influence on also how we imagine and think about the future of our machines. Okay, so one of the first things I tell everyone in my class is that, you know, when you study digital culture, technology, you don't just study this object, right? This object is an ecology, right? It's not only a series of technologies, but it's a materials. There's stuff that had to be brought here inside this machine, right? Rare earths, cobalt, other silicon that had to be manufactured and brought from other places, right? There's labor inside this phone. There's also a worldview. This phone isn't just about a phone, right? It's integrated into my watch. It's about me, the way I think about myself and count my you know, every day. I don't know. Do any of you have these little watches? They're addictive. You're constantly going off on your iWatch. Okay. It's a whole mode of being social, right? How many of you use social networks? Any social network? All of you, right? Don't be shy. I know you're going to be twitting or TikToking or doing something in the midst of this talk. You can't resist. Maybe you're swiping left and right. I don't know what you're doing afterwards. Anyway, the point is, this is obviously a way of life, right? It's not just about computing. It's about living. This is a conduit into a very large ecology of information, materials, labor, lifestyle. So everything from ideas of how we see and also, you know, one thing I have people think about your computer, think about the metaphor of the desktop, right? What's a desktop? a desktop comes from a history of working at desks, right? And having files and doing all these things, right? So those histories of labor in the office and bureaucracy are all inside these machines. So when we're studying this machine, we can't just think about, you know, I'm going to just think about the programs, or I'm just going to think about this as an object. I have to be thinking about all the ways we know the world, the ways we experience the world, the ways we ourselves come into being as people with our technology, and then in return, how the ideas about who we are and how we live feed back into the types of technology we build, right? Are there questions? I also talk really fast. I'm from the Northeast United States, New York, Boston, Philly, those are my hometowns. So when you come from those places, you talk super fast. So at any point, please slow me down. So I want you to think about this. This is your big thing. I want to hear questions about it. I don't want pure raw silence. What does it mean? Computing is about computing, or it's about living. And Nicholas Negroponte, really famous guy, and started with something we called Architecture Machine Group, later became the Media Lab at MIT, which pioneered a new integration of the university with corporations, and a new form of, the vision of the lab was to build the contemporary, partially to build this contemporary digital culture we live in, because they wanted to integrate all the medium, print, cinema, radio. They wanted to bring it all together. And today, in many ways, right, that's what digital computing, you know, our digital media environments integrate, right? Hearing, seeing, biometrics, so much different experiential and types of data, right? So these are the kind of things that Media Lab was at the forefront at a certain moment, and also at the forefront of the kind of idea of venture capital and innovation startups. And a lot of this comes out of a book I just finished, Smartness Mandate, for those of you who are really interested in smartness and AI. This is a book about how we became so smart and intelligent as a society. But these are the kind of places I work on. So this is a operations center for Songdo, which is a smart city in South Korea, a little bit north of Seoul, pretty close to the DMZ. And Songdo, and what's interesting about this, so this is an IBM operations room, and a lot of cities all over the world have these. Rio de Janeiro, New York City, Tokyo. You'll see these kind of operation rooms, Hamburg Port. Lots of places have these things. And what's really interesting, and we'll talk about it a little bit, is that this is kind of a performance, because what you have here are all the city is covered with cameras, and also you have environmental sensing, you've got traffic cams, you got all this stuff. But the truth is that all of this data is being analyzed through AIs and algorithms, and actually this is just a performance. People can't see all the images that are getting caught. They can't see all the data. It's too much data for human analysis and perception. And one of the questions, therefore, is why do we need that wall then? Because you could actually have an operations center with no screens there. You would just sit behind more of these monitors, and then when something happens, it flags it, and people cross-check the image. This is actually an aesthetic, and that makes us think a little bit also about why do technologies look a certain way? Why do they feel a certain way? And a lot of that is, of course, about how we experience, right, these information systems. So this is actual Songdo, and it's got lots of really interesting features. So it's called smart or ubiquitous city in Korean parlance, which is to say it's got all these fiber optic cables and a lot of bandwidth capacity. They've recruited all these universities, New York State universities, universities of Texas, all sorts of universities have outposts here. So does Samsung, a bunch of R&D and biotech. So this is all supposed to be high-tech, supplemented by an incredible infrastructure. And what's interesting about these cities, and it's built by, it was built by Cisco, which is a US-based kind of internet sort of communications infrastructure provider. And what's the interesting thing? We call this a greenfield city. And why do we call it greenfield? It's because it was literally dug out of the South China Sea, and there was nothing there before, and supposedly. And this is part of a new infrastructure of cities that you would see popping up all across China, Malaysia, all over the world right now. There's greenfield cities, although there's also smart cities. Dresden has a smart, Hamburg's the smartest city in Germany, Amsterdam, Barcelona all have initiatives, right, to be ever smarter. And smarter usually means more bandwidth, more capacity to sustain more computing in the environment. Now, there's some other interesting things. While you usually don't think about infrastructure, I'm sure mostly you guys study, I don't know, what do you guys study in this class, like social networks or? Today we're going to focus on the kind of backdrop of, so today there's a new battle globally about infrastructure, okay, the actual infrastructure for computing the material. So this, for example, is a map of China has something called the Digital Silk Road, which is all the data centers and smart city initiatives. And the idea is that they're going to, has any of you heard of the Belt and Road Initiative? Good. Occasionally. Good. Yeah. Well, you will now. So that's what education's for. So China has endeavored over the last, I'd say 10 to 15 years to kind of integrate all the world's supply chains and logistical systems through what they're calling the Belt and Road Initiative. A lot of it is around materials, production, so on and so forth, but a big part of it is what they're calling the Digital Silk Road, which is a series of supposedly environmental monitoring. So there's a lot of surveillance and GPS and GIS, and also data centers and data infrastructures that they're rolling out in places like Africa. Now, before we jump and say, oh, just China's doing, I want to alert the fact that the United States, and we'll talk a bit for this, throughout the Cold War, built an entire satellite. All of your GPS and GIS is the history of basically military infrastructure set up during Cold War for the U.S.-based kind of satellite space surveillance systems that allowed both weather monitoring, so that most of our climate crisis information, climate change information comes from these satellites, but also, of course, were also used for strategic and tactical reasons. And of course, we know that there are huge wars over silicon chips. How many of you ever go by the Infineon factory, Taiwan Semiconductors? This is like the news, right? You guys are getting these chip factories. Maybe you've heard the term digital sovereignty. All of these, so there's a new war happening globally by many people, of which, interestingly enough, you are on a site that is quite central to it, that is about securing the resources and ability for computing itself. And so for that reason, you have the effort by the EU and Germany to secure chip production without dependence any longer on the Chinese. And you're having these battles over Taiwan, and you're having a lot of intellectual property battles as well. And it's a very complex supply chain. There's a great book called Chip Wars for those of you interested. So when we're talking about digital life, we're talking about the very infrastructures and territories and habitats, our everyday life that we actually inhabit, and that maybe you've been thinking about, or maybe you haven't, but increasingly digital technology and securing digital resources and the digital ecology are shaping the politics and economics of the world we live in. Not only also in the social networks with the alt-right and with reactionary politics, but also at a very infrastructural level, which you probably maybe think a lot less about, that every object, everything you're working on needs those chips, needs those materials, and that this has become a central feature. Now, beyond that, there's also a whole feature to digital technologies that's about the future, right? And about future making. And that's very much concerned with the question of how we imagine. So this is the marketing, and all the marketing of these East Asian smart cities and greenfield cities is very, very banal and very, very low tech. You'd think they'd have better graphics, but apparently that takes away from the reality effect. And so this fantasy that they have, largely pervading these spaces, is about the idea of ubiquitous technology that is, all this tech creating forever growth and abundance and economy linked to greenness. So one of the things that I'm really interested in and we want to talk a little bit about, and that's why I gave you these articles, is a little bit about a real interesting equation, which is how has bandwidth as rates of bits transferred between connections in unit time come to equal sustainability. Like literally, you will not talk to an engineering at this university. Go talk to them. I do it all the time. Who does not think more computers are the route to more sustainability? Like that we need to have smart cities, smart cars, electrical cars, autonomous driving, optimization of every industrial process. That's the way that we're going to ensure life, maybe on Earth, is going to be through computing. So how have we come to see? Now this should be shocking. Why is no one shocked here? I mean, does anyone think computing is green? Does anyone think large language models are green? The answer is no, they're not. In fact, one of the reasons there's going to be like total collapse of the thing is like no one has enough energy for the processing power. No, it's not green at all. But the interesting thing is that it doesn't matter if it is or isn't green. We're going to make it green, right? Because we really, really believe in this equation. We really think at this point the future of our economy, the future of our species, the future of our habitats are about computing. And this is a really, really interesting thing for me as a historian. Because my job isn't to say that's wrong or right. It's to, although I have my opinions, obviously, my job is to actually ask how come that's something we just don't think twice about. Like when I say it to you here, you're like, oh, that's insane. But when you go home and you kind of get the ads from Amazon for your smart home that's going to save you all that electricity with the LEDs, and your smart car that's going to do that's going to be an EV, and you get, we get the discussion. It seems unquestioning that, of course, these things will somehow work out. And then even things like cryptocurrencies and large language models that are very energy intensive, we think, well, we can make green Bitcoin, and there's all sorts of schemes to do this. So this is a super interesting point, and one of my points today is what kind of history do we want to tell? How do we explain how we get to this, and how do we understand it? And the other thing that's really interesting is, when I go to these places, and I also work in New York, and I have projects right now in Nairobi, Hamburg, Delhi, all on smart city developments. And when you talk to people about like what's going to happen to all of this, like is it gonna, like what if the South China Sea rises because it's at sea level, and the whole thing's flooded? Or what if nobody wants to live in this lovely place? Like what if it's boring? It's not Berlin. What if this fails as a investment? And the interesting thing that they all say is, well, it's a test, an example, it's an experiment, it's repeatable. In short, it's like a prototype. And I'm really interested today, we're going to talk a little bit about how it is that we've come to kind of see the world as sort of this experimental, prototypical space. And I'm really interested in this experiment because it's not just there. If you go to one of Google's, for a while they were developing this large language learning model that was called BARD, and they would say BARD experiment. And part of that was about, evading legal responsibility, but part of it's really interesting about thinking about what does it mean to actually learn from and develop new technologies on your users, right? Like, we train the machines, right? They're learning from us all the time. They're experimenting with what we come out. And one of the issues that I had you read about with a very short essay on the demo is what's the politics? Like, so who's responsible for BARD? What does saying it's an experiment do for the type of responsibility or kind of impact of this technology? Very quiet class. Okay, I'm expecting by the end of this that you guys are all going to ask me a lot of questions. So this is sort of, for me, this is partially what I talked about with the demo, and partially I wanted to link it to design question. But how did they develop? Yeah.
Before we move on from this point, in one of my classes this week, we had like a mock. It was my French class. We had a mock argument or debate about artificial intelligence. One of the points that one of my peers brought up was with self-driving cars, if there's an accident, who's at fault? And so your tangent here about experiment, who's responsible, like who's evading liability and stuff like that. I think that's something that I increasingly think about as well with artificial intelligence.
Yeah, I think it's
it's clear, but
yeah, no, that's a brilliant point. That's exactly the question, right? If it's always learning, if it's always an experiment and it's not actually being implemented, because part of the reason that Google is putting that there is to tell you that, like, this system might make errors, it might do things wrong, it might give you mis or disinformation, but in some sense it's only an experiment, so this isn't the final product. And that's something to think about, because whether it's software where we have versions, or whether it's large language learning models like this that are being projected as sort of trials rather than actually being implemented. And now there's things happening, like, for example, in Britain, a company called Palantir has just bought up all the data securing and management services for the National Health Services of the UK. And there's some serious questions. And the way they got in there was actually originally during COVID, saying, we'll help you build these apps and these data tracking and data management systems for COVID. It was just an experiment. We'll test it out. And now they're here to stay. They're now keeping that data. So there's always real questions about who owns stuff, where's it going, what's happening. So this is kind of an overview of the stuff I work on right now that I want you to be thinking about as I give you this little history. Although pretty soon I'm talking so long that you probably have questions even about this. I don't know how long I'm supposed to talk for. Alexander. All right. So this brings us to another component of our my current work, which is about thinking about how we sense the world is linked to what we think is intelligence or smartness. And of course, smartness and intelligence are not exactly the same. So it's really interesting that we have a whole series of things we call smart and a whole series of things we call intelligent. Usually when we talk about artificial intelligence, interestingly enough, we tend to kind of worry about the human. It's going to kill us off as a species. It's going to be smarter than us, blah, blah, blah. When we think about smart, it tends to be like nice fuzzy things. My smartphone, my smart home, my smart car, like nice stuff. And that's really interesting to me, is to think about smartness as the sort of intelligence manifestation for how we deal with environmental management. So smart cities, right, are supposed to deal with like environmental collapse. They're supposed to be good environmentally. They're supposed to use our computers to help us manage life every day, whereas artificial intelligence is somehow supposed to replicate cognitive decision making. Of course, the two are very closely linked. We can't really, like I mentioned, you know, the algorithms and machines and AIs that are reading all this data that's streaming in from these systems are obviously making decisions. They tell human beings, oh, some car just ran a red light, and you should check this out. So they're making decisions, and they obviously also have ideas encoded in them about society inside the technology. And if you have questions, we can talk about that. I tried to suggest that in the article I asked you to read that I wrote about demoing and Nicholas Negroponte's work. It was a lot about the specific context of the urban environment that led to that. So these are also they're what we call they're affective or cognitive capitalism, but they're also attention. They're platforms for accumulating attention. So this is the never yet arrived, but now increasingly imagined Google Glass that was going to integrate your face. But I actually found that Ray-Ban has actually entered a relationship with Facebook to build these glasses that will actually constantly record so that you can like be streaming on your feed, I don't know, whichever social network or TikTok, that your glasses can kind of live stream, share your unique view of special moments by live streaming them through your glasses direct to Instagram and Facebook. And they have a whole meta-oriented platform developing here around this, with Ray-Ban, which makes sunglasses for those of you, or I don't know, glasses, that is basically increasingly trying to network, right, your body and yourself into the technology, right? And we also have actually Neuralink, that's Elon Musk's vision of the kind of future of our relationship to human-computer interaction, that he wants kind of directly jacked into your brain, and actually modeling. And actually, they do have FDA approval for testing, although there's concerns about the technology right now. But this sort of technology takes even more ominous. This is actually a drone operator in the U.S. military with an electroencephalogram kind of sensors put in on his head, and apparently your body gives off electrical impulses a few milliseconds. So before you're conscious of you picking an image, he's an analyst looking for things for drones to target a few seconds further. So this idea of hooking human beings directly into the machine to circumvent maybe what we would call conscious decision making is sort of part of this kind of dream, right, of ubiquitous computing and smartness, and obviously has some maybe potentially excellent, but also some potentially lethal implications. Are there any questions for the kind of survey of the present? I've already gone for half an hour. This is taking, I'm sorry, I'm going slower than I thought I would. So I'm not sure, like, if I'm supposed to lecture for the whole hour and a half. Alexander?
It's okay.
It's okay to go?
Yeah.
Okay. So there's a whole series of questions about how did we get, so that world where we live in this attention economy, fantasize about this ubiquitous computing, kind of have a new geopolitics around infrastructure, and where questions of experiment and demos and prototypes become central modes, right, by which we introduce technology and transform society. those are contemporary issues that I study in my work. But I also want to ask, right, how did we get here? So part of trying to understand this relationship between human beings and the environment comes back to a little bit about history. What are some of the ideas that animated computing and the history of computing that led to our present? So one of the things that we often start with in media studies, but there are other places that people could talk about. For example, I could talk about weaving and say that that's the start of computing, because after all, women's labor on weaving was some of the first places where you actually had a sort of algorithm, if you will, for pattern making and for actually, so it's kind of an early programming. So weaving machines have these cards on them that tell the loom kind of where to go. And in many ways, one could make a different history that demonstrates that, you know, contemporary computers and artificial intelligence comes from a whole history of labor, craft, different types of sexual work. Okay, so I'm saying that because it's really important for you to understand that the histories we tell create different understandings of our technology and inform how we're going to be building the technology in the future. So, but my histories tend to start somewhere around World War II and the emergence right after World War II of a new word called cybernetics. And until like the 70s, when digital came in, that's pretty much what people used to talk about computing in a very broad sense. And it had a very weird title, Control and Communication in the Animal and Machine. And I'm going to go fast because my class has already kind of gotten this. But those are kind of weird terms, right? And and these ideas were coined by someone titled Norbert Wiener at MIT. And the idea about this was that you were controlling, in some sense, you're predicting the future. So it's not control like you might think direction, it's control in terms of prediction. And the idea was that actually what you were predicting was communication, whether or not a message would arrive. And that message arriving had to do with actually thinking about whether something would happen. So, for example, if all of you love me, I know you do. Anyway, and I say I love you, and everybody loves everybody, there is what we would say no information in the channel whatsoever. And my students have seen some great movies to this extent. Why? Because we all agree and we all, you know, there's no dissent. However, if I tell my special friend that I love them and they don't love me, then we have information in the channel, because it is possible that they will not respond. The only way I know if I've gotten anything is if there's a response that wasn't expected because suddenly they walk out of the room or something. Then I know that I have communicated a message because we're not all in agreement and all feeling the same way and nothing is changing. The only way, that sounds very strange, but I'll explain it to you a little more. But the idea is that it's a world comprised out of communication. And interestingly enough, from the very beginning, this term had in it an idea about government. So Norbert Wiener picked the term Kubernetes or steersman that is also what we call a governor. And a governor can be either something that governs a machine or something that sort of is part of what we call government or politics. So from the very beginning, the way that computers were imagined before they were even, well, not all computers before actually these terms were actually people doing calculations. They would be called computers. But, you know, once this entered, the idea was everything could be thought of in terms of cybernetics. So I could rethink this classroom in terms of a communication channel. I am the speaker, I am delivering a message. you are falling asleep, so you're not receiving it. And we have, but that's a statistical condition. Only 5% of people in this room are going to receive my message because they stayed awake, but still, that's how we think about that. Is in the mathematical theory of communication is not meaning. It's the amount of information that's transmitted over a channel, and that's only judged by whether or not there's a response, i.e. falling asleep or staying awake. Now, these very complex ideas of communication came out of, as I mentioned, World War II, where there were many different ways of thinking about the enemy other. Okay, so one way of thinking about your enemy in World War II was, for example, here in this U.S. propaganda, we see that the Japanese are represented as sort of animal, different, other, racialized, right? So there's the racialized enemy other that's radically different from yourself. So this is one type of other that obviously was very prevalent during World War II. The other type of other, though, was a little more abstract, and it came from aerial bombing. And in fact, the people who came up with the idea of cybernetics were doing work on anti-aircraft defense. And one of the things they started to notice is that pilots, when they're getting shot at, have a tendency to be repetitive. So for example, I get shot at, I always veer left. Okay, and other people veer right, whatever. And essentially, if obviously you can start counting, right, and trying to predict where the pilot, and in theory, if I could figure out where the pilot goes, I can shoot down the plane, right? And this is during the Blitzkrieg, when the Germans are attacking London at great force and speed. So the new speed of warfare suddenly demanded a new automation in kind of targeting in terms of your weapons, and also evasion. It didn't really work yet at the time. They never managed to really fully successfully incorporate these ideas. But the idea was maybe we'll get a lot further with thinking about, so the problem is here I see a plane is going, but of course the minute I shoot at it, it's going to move, right? Problem. So maybe instead I have to think of the gun as talking in a pretty aggressive manner, of course, to the plane. There's a lot of violence in computing. Don't ever forget it. So anyway, they're having a conversation, and if I think about it in terms of what they labeled feedback, which is to say, I try to anticipate, I know that I'm communicating with the plane, and when the gun goes off, the plane's going to move. So I need to be thinking about that relationship instead of just trying to figure out where the plane's going to be according to where it is now. Because obviously it's going to change. So this aggressive conversation put the idea into the world that basically, maybe we're all talking to each other all the time. Maybe I can think about your social network. What do you think that is? That's people having an idea, modeling in a computer system the kind of interactions they think you have socially, right? Like, so you list maybe what you like and what your favorite music is and who your friends are, all these things that we put into profiles on dating services or social network services or stuff. All of those are efforts to basically automate and predict, right, the way we interact with other people or things. And a lot of stuff is about things. So this was a world, and the other innovation was, what? One error is to think that humans are humans and machines are machines. But you'll get a lot further shooting down planes if you stop worrying about people as being special and start looking at them as statistical patterns. Just like AIs don't really see me the way you and I see each other, maybe. They see me as a statistical pattern of behaviors, particular words I'm putting out, particular actions I'm taking. And I could be human, but they could also learn from birds. They can also learn from container ships and boxes and robots. Okay, so they they don't think about me as a human being. They think of me as a pattern of data that's communicating in the system to other little patterns, and they're trying to learn and model those patterns. Yes, I know it's not a lovey-dovey view of the world, but this is the cover of the 1956 book that made this the most popular thing. So back in the day, when people read books, this was like a bestseller. This was it. This was like hot tamales and like New York Times bestseller. Everyone wants to know what cybernetics is. And it had this rocking cover that, interestingly enough, is what we call it's just two little, what we call black boxes talking to each other. And what do we notice? Is that we have black boxes and then we just have the arrows. And the thing we care about, right, is the arrows. We're not interested if that box is a person or a machine. We're interested in the communication exchange. And that is a radical new idea that fed into and helped develop. So Norbert Wiener was friends with some other people. I don't know have you guys talked about Shannon and Weaver's. So this is an image of the mathematical theory of communication, which is essentially an idea that is quite both hard and easy to think about, but came from thinking about these little black boxes, which is made basically that, and there's a famous thing they say about this, and this underpins all our communication technology, even today. Information is not a measure of what you say, but what you could say. And I guess you're a linguist, so you would know even more about this than me. So Alexander can give you like a full lecture, I'm sure.
Shannon and Weaver.
And Shannon and Weaver. But, that's a weird thing. So what do they mean? Remember I said control is about the future? Remember you're worried about where the plane is going to be? Well, what I mean when I say what you could say, like when I build an information channel, let's say I'm putting up some cell phone towers. I want 6G. That's the fantasy right now. What do you think I care about? Do you think that the person who's engineering the communication system for this phone cares about what I say to you? Like if I'm sending pornography, or if I'm sending pictures of my dog, or if I'm sending, do you think the channel is built around that? No. Is it built around, what particular I'm saying? No, what it is it's built right around the specs of human voices have to be carried, let's say, between these particular ranges, right? There's a certain amount of data that's going to get processed and sent through images, or, I'm sending photos. So we need to know that the channel is going to be able to send across and package this level, these kind of signals at these kind of ranges, right? And digital kind of makes these things commensurate, but we have to build our systems not according to what I'm actually saying right now, but what capacities, how will we use the 6G? What are we going to send through? How much more work? How many more documents? How many more texts? How many more videos? I don't know, whatever it is we envision that we'll be doing in the future with our channel. Now, I can't accentuate to you enough how important it is that, this all seems like, what would it have to do with my everyday life? Why would this matter? But think about it, we're always kind of a little bit in the future, basically. All systems of communication and essentially control have a new tense. We're thinking about what could be in terms of who we're becoming. And I think that's really interesting and really important. So this kind of idea of a closed world with black boxes also shaped a lot of the Cold War. Okay, so this is the first computer system that had an interface, and it was the IBM Sage system that was deployed for aerial defense and monitoring along something called the Dew Line in northern Canada, looking for Soviet bombers. And this had these guys could actually touch that screen and get data about where the American troops were, what foreign troops were, and this actually became the contemporary air logistic, the air system. Why am I suddenly forgetting the name of the air line ticketing, and also, contemporary air travel monitoring. But it was also the first form of interactivity that was happening. Now, I'm bringing this up because it shows you how ideas about difference, race, space, what constitutes communication, also become environments that we inhabit. So these ideas, so here's Herbayer, these are design ideas of the control room, for example, from the 1950s. And interestingly enough, we might think about this because starting in the 90s, when cable news network developed, you started to have these, I don't know, you guys probably don't even watch TV anymore, but anyway, if you did, there would be something called a situation room, and you would see like the war of Iraq, like live broadcast through these rooms. So this idea of us being surrounded by media and kind of managing the world through our devices or through our things started out in these closed rooms that then, in many ways, have now become the whole world, right? The open world. And some of the most famous designers in Cold War United States. So this is a very famous installation called Glimpses of the USA that was staged in Moscow in 1959 by designers Charles and Ray Eames, and it was a rocket bestseller. It was so important. Was the first installation. It doesn't look very computational, but you'll notice it had so many screens. People were like overwhelmed. They're like, oh my God, I can't look at this many screens at once. It's too much data. And what that tells us is actually that, interestingly enough, people had to learn how to, we assume that our attention is just short, that I can't sit through this thing. But of course, part of that is that I've spent my whole life in front of, around, and immersed with media, so I'm being conditioned. And the interesting things that I'm bringing this out is it shows you how arts, designer, humanistic filmmakers are also part of computing. They're part of creating the environments and the attention fields that allow us to begin thinking about all the windows I currently have open right on my desktop, and maybe further. It's also really important to remember that aesthetics and politics always go together. So this is actually in the same 1959. This is Nixon and Khrushchev. And actually you can't tell because all the pictures are black and white, but this was bright yellow. The American kitchen was this amazing yellow thing. And it was about a debate about, communism and capitalism, and everyone was like, this is so crazy. Like, the Americans show up with like a bunch of screens and a kitchen. That's how they're going to win the Cold War. Well, maybe, actually. And people love the yellow kitchen. They wanted one. So this was a deeply political thing. But it's also important to remember that to make computers, to make this vision of the world where we think that everything is made up of communication, and the idea that when the designers put this together, and I'll show you a little example. So I don't have the example of this. This installation actually was never recorded, but the idea they had was that the viewers had to pick from the screens and like make their own story up in their heads, sort of kind of hyperlinked vision. And later the same designers built an installation, because remember, at first people were like, who needs these machines? Like, only big corporations or maybe scientists calculating some big number. Why would everyday corporations, why would I need a computer? Why would I need a cell phone, in fact, or any of this? So one of the things that's important to realize is that before we even had these computers that did all this multimedia stuff, and before the whole world became about communication, people had to convince people that that's something they wanted. That actually the idea of computing came before the computers. So just really quick, I'll show you how IBM. So this is a very famous. Sorry, for some reason I have to stop my little show. Sorry. In order to show you the film, which apparently is showing up on my. So, in order to convince people, I don't know if this is interesting, please stop me also, there's a lot of information. So in order to convince people about this idea, and also, interestingly enough, for those of you who track smart, think, intelligence, IBM's motto, IBM was one of the big corporations, and I was going to show you another movie about IBM and kind of the SAGE missile system and kind of aerial defense that tells you a lot about the Cold War, but I don't know if we'll have time. When does this is only an hour and a half, right? Okay, so I have so much fun things to show you. This is nothing. Anyway, so I'll just show you really quick what they built for the fair to convince people that that computers work just like people think. So the motto of their exhibit of IBM was think. When Apple crashed in being like, we're going to destroy central computing, they were like, think differently. And now I don't know what we're thinking at all, but okay. And now it's descended into BARD, automate thinking, I don't know. Anyway, you come up with the slogan. But this was staged in New York at the World's Fair in Queens. And I'm just going to kind of really quickly go through. You were taken up into this, so there's a lot of images of, so a big part of this marketing was to show how simple and like even little kids can use IBM machines, and you'll go up into this making things really cute and like really introducing people to these machines and also linking them to work and to everyday life and to all these things. And so I'll just, so you were taken up into this, this oval. So I'll just, there's people coming in. You're taken up into this, you were taken up into this oval thing, and you were seated in this really big theater for this installation called Think, which literally hundreds of thousands of people saw. And this is similar to what they did in Moscow, too. And you were shown this huge wall of screens, and then the point was to show you all this data and each section of the installation had ideas in it, like so to show you about computing. Like, so this is around 2 binary. This is around, they used the example of games to show you how computers calculate what you're doing, organize cities. And so they used a woman setting up her office, her dinner party to show you what a machine does. That machines make decisions like you making a thing. Now this doesn't look very impressive maybe, but people left it being like, that was mind-boggling, changing. Again, attentively, it was so hard to watch. People were sick. But what you'll notice if you watch the whole thing and go through the archive is the way that it keeps showing patterns. And that was a big idea. And the Eames also started running new courses at Berkeley at a bunch of different universities in the United States, where they said the job here is to be shown as much information as we can in like a short amount of time, and to make you, as the student, find a pattern, just like a machine. So the idea that humans and machines are kind of thinking alike or compatible was slowly evolving in both design and in architecture and other places that I don't have to develop immediately. But it goes without saying that it's not hard to see where the kind of imaginary of the control room begins to be grounded in this new architecture and aesthetics. And in fact, as machines, and also the way that these ideas of communication became central, you saw people organizing their dinner parties, people playing football, like all sorts of things that all could be thought that the whole point of the Eames was like all of that links to computers too. That things you wouldn't think are about digital culture are about digital culture. And they have even other more brilliant things that they can show. Now, one of the interesting things is, of course, we started with smart cities, is the way that computing also changed the way we work. So throughout the 60s, you start seeing this new architecture of the corporation where suddenly you lose all the walls inside, and the buildings were just built around these machines. So you have this idea of a new global corporation that spreads all over and is organized basically around communication and information. So this is the redo of the architecture for Westinghouse, which was a really big energy company. And this was the IBM lobby as it was changed in the 1950s. And what you might notice, and this came along also people with a cybernetic house. So everyone's living in these kind of encapsulated bubbles. And so that's part of what you read about, right, in the Society of Control, was the way that we have to think about computing and how it transforms our very ideas of space and time through these ideas of communication and control. So just to show you, like, this is an old school building. This is the Rockefeller Center in the 1930s, and like that's a building, right? Like it's all heavy, and it's got hierarchy, and the top brass sit at the top of the building, and they lord over, and it doesn't have what we call a curtain wall, which is to say the support isn't on the outside. There's support beams running through that building, which, interestingly enough, also makes it more secure. One of the reasons, of course, that the World Trade Center, for example, fell is because it had curtain walls and only had one support beam, so it's pretty easy to knock down. Here you have support beams all over, so it's a very secure building in that sense, but it's also one that you can't change. The guy in the corner office, you can't move the walls around, you can't do anything. It's like the corporate structure replicates the architecture of the structure. And you know, this is in the 1960s. These are the first of the corporate office cubicles. Now, these are like long ago. By now, we all get to work watching each other just at home all the time. Well, now we just work everywhere, right? Well, maybe not here. I don't know. In America. And these are what we would call the spaces of control. So when, along with the new computers, they changed the entire office structure and architecture, right? So the new buildings that you see were full of glass, and the walls were moved to the the support was on the outside. And the reason you have a interior like that is it allows you to reorganize your office at any moment, right? You can change who's in the top corner, you can shift who's higher and lower, you can fire people, add people, do whatever you need to do in a kind of flexible plan. And the idea of that flexibility, again, mirrored this idea of a new sort of organization built around information and communication. And you know, it's taken, maybe it's hypothesis. So these are Apple stores. So now you see, like, forget it, we're now going to lose the walls entirely and go for all glass. You know, if, I don't know, there's like an all glass on Fifth Avenue Apple store that's like, and in fact, you no longer have a point of sale, right? So that the Apple Store has dispensed with having to go to a counter in one place and pay. They've made the kind of entire environment. And of course, with the internet and shopping now everywhere, right? I can shop. So this is totally, and you can see that as we move towards a more internet and networked society, we have a more information has flowed outwards. But again, the model is always that we're all communicating all the time, and that's integrating us into these networks. But my point about all of these practices in the society of control is that it doesn't just happen. Like, we didn't just wake up one day with all our computers and the internet. People had to build it, they had to imagine it, they had to convince everyone to use it, and we had to come to kind of desire or want this. And so there's also a lot of place where different people had different ideas. I don't have time to go into all the fun and exciting futures people imagined, many of them that have not happened yet. But for us is the question like, yeah, what do we want our AI society to be? Because a lot of times it makes it sound like we just need more computing. It's coming, it has to come, but we don't know what it's going to look like. We don't know what architectures are going to happen. We don't know what kind of social relations. So here's another example from Diller and Scafidio. These are two really famous architects. This is a famous, this is the ICA Boston, where it was one of the first buildings. They just totally opened it, like leans into the sea, and you can almost not tell the difference. And they actually built this space, I guess, in Switzerland, which is just air. So these are kind of ephemeral architectures, right? That, and in many ways, this seems like an old and modern, but you can see everything's glass. But you know, the funny thing is, you could build this city any way if you wanted to, right? Because in theory, the actual structure of the city and the structure of the computing that's in this environment are not actually one-to-one. So that interests us, why we also choose to build things sometimes the way we do. So I think we're 1 hour in. I don't know if you have any questions, but I have a few more things that I can keep going.
Do you have any questions at the moment?
I mean, I feel like I've loaded you guys down here. You want to watch some more movies? You have a question?
I have like 2 talking points. I don't know if question is really the right word, but one about the beginning of your presentation, or your talk, about the histories we can tell, about how we come to this, the part I'm interested in this work in progress, or something is an experiment. Do you see some connection to like postmodern art and the performance art, where we like do things and just say they're not finished because they're still developing, like the society is still developing, and we're just living in a constant state of work in progress, like all life is work in progress? And this, I don't know whether this is influenced from living in the digital age where everything is still developing, or there's a potential to develop because I don't buy a finished product anymore, or this is acceptable because we started to live that way. This is a question I would ask.
It's an amazing question. So in the discussion about this, and also I have some other material, but I think that's an amazing question that relates broader to this question of society of control. So exactly at the moment that we're getting more mediated, artists, activists, people politically minded are asking, how can we use these technologies or in different ways, so that it's not just all about drone operators, right, and people killing each other. It's also maybe about other ways that we can relate to each other, or maybe not just about corporations, right, taking our data. And right at that moment that there's all this mediation, you see the rise of performance art, and particularly like feminist performance art. In my first book, I write a lot about the kind of some effort to create things that are ephemeral, unrecordable, maybe don't fit the pattern, like you can't actually fully analyze or deal with it in that sense. So you see the rise in art, particularly, you know, like if we were to look at, you know, cut pieces, like famous pieces. I don't know how familiar any of you are with 60s and 70s performance art, but you know, even starting, you know, there was all these groups like experiments in art and technology is one group that started kind of in the 60s. Namjoon Paik did a bunch of with Charlotte Mormon. So here's some really interesting examples for those of you. There's a really famous moment. I don't know if we need to hear it, but this is Charlotte Mormon. She was played naked with this TV cello as a kind of live performance that was, so in general, Namjoon Paik was always experimenting. He was an early experiment with electronic media to try to like kind of mess with the image, like the transmission of the communication, kind of maybe like early glitch art or what have you, for those of you who are familiar with this. So Charlotte, it was quite the thing, and she got arrested a couple times for being naked and so on and so forth, but in an important way too, because it was also a moment for feminism and for rethinking sexuality and bodies. Yoko Ono, Cut Pieces is another famous piece that comes up at the same, and all these people also, so I don't know if there's any images here. She also, I mean, it's actually quite an intense performance. She would sit and she would have people come over and cut off her clothes. It actually becomes quite violent, actually. It's kind of almost upsetting to watch. But these sort of practices all sat within an art group that a lot of people really thought a lot about cybernetics and art technology. 9 Evenings, this is another very, very famous set of so theater and engineering, so a new kind of art and science that was kind of broadcast. This is a very famous group. And there was a bunch of really cool, I mean, there was one, well, they almost burned down the MoMA at one point because the Museum of Modern Art in New York, because they tried to have a robot commit suicide. It wasn't a real robot, it was like a little built thing, but it caught on fire and the whole thing caught on fire, and so things got out of hand. But that was, I think, part of the game with control, was to try to really play with that term and what it means, because control can mean top down, like people surveying you, telling you exactly what to do, controlling everything, controlling the future perfectly, or it can be a world that's about prediction and what people might do, and it might be something exciting and experimental. And at the time in the 60s and 70s, and maybe that's the struggle we have today, people were trying to play with all these things. And like John Cage, for example, a very famous musician, all of these people deeply engaged with questions. This is a very famous exhibition called The Machine that started, actually one of the more famous one is actually the Cybernetics Serendipity, the Computer and the Arts, that came out in London, actually, again, also in the late 60s and early 70s. And these were really, really important places where people tried to think about the different possibilities of computing. So the history of computing is that it's closely linked to corporate and military and state interests, but there's also always people who are trying to imagine different ways we could relate to each other through our electronic media. And so that's a really critical question. And it's what you guys should be interested in, you know, like ultimately I only write these histories so we can ask questions about why we think we have to use our phone in a particular way, or why we think this is the only thing artificial intelligence could be, is to write my papers for me so I don't have to do my research, which isn't the only thing. But also, of course, we know that the way AI is currently structured, I don't know how much you guys talk about AI. We can do a different course on AI. I'm doing a last course on AI. But, you know, we know that to have those large language learning models, we know that only certain people and certain corporations, certain entities, certain agents have enough money, size, servers to even get those data sets, right? So it's obviously not a super small and democratic system, and so there's real questions about who's going to own the data, how we're going to deal with privacy, but also how we're going to deal with wealth distribution and other things that come from that. And I think for artists at the time, those were the same questions, and they wanted to create a kind of alternative vision to computing than maybe just IBM's.
Further questions, everyone? What do you say about Translatotron 3 of Google? The live translation of speech? And
I spent a lot of time using it, so I have some experience because my German's so bad. But, yeah.
Okay.
Well, actually, I do. I talk to like the people.
Not on the system, not on the server. Live translation, like a universal translator in Star Trek.
I can't wait for the.
Yes.
I'm waiting.
But if you talk about Cybernetics or Cybernetics, that's the next deal. Get a pointer and or a headset or something like this, and have a live translation. What you hear is what other people say. You get it live to your ears, and the question is, do we talk to each other at the moment from this time on?
I mean, I think that, again, that's for us to start engaging with. And it's interesting. I love that question because, we don't usually think that that's like the next frontier for politics or for social development, but it is. Because we have to invent how we're going to relate through that technology, and whether we just think and whether we pretend it doesn't exist and that I'm just understanding you, or whether we want to make the question of translation part of it. Because at the end of the day, I mean, it's possible I never understand anyone. I'm open to that idea. Like, I think we overestimate how much we get each other, I mean, obviously humanity wouldn't look this way if we all really understood what we were each other saying. But, I think the question of how we let us or engage with what it means that there is a machine there. We know it has certain limitations and constraints. How are we going to train it on what language, and how we're going to understand the question of interpretation of what people are saying, assuming that they're, that we're all in some ways would then be in the position of being like in a second language. Those are really important questions. Those are humanistic questions about how we're going to imagine that. So on one hand, I can't wait because German's really hard. No, really, I speak French, Hebrew, and English, and I have to say German is not structured like the above special. But it's also a different form of thinking. So we also have to deal with neurodiversity and like, is it a diversity problem? Like, are we reducing, for example? Every language comes with its own form of thought, right? And it does change how we think. So these are really not just kind of secondary things. I think they're foundational for the kind of societies we want to build, and are things we have to be obviously thinking about and they're the positive sense of experiment, because there's so many great things. Like I really happen to love 60s and 70s experimental art movements. There's so many things we can also do with this that is really wonderful, but it does mean, being able and creating the situations where we do it. So now we're all going to play with language translators.
No. I'm waiting for it. Translatotron 3. That's the next thing. A couple of months ago, I thought about that we will get it in late 2024, but now we have late 2023, and I think we get it in the first quarter in 2024.
Whoa! Well, we should do like a workshop class. Actually, in my other university, we were doing a bunch of. I almost made you guys do a prompt. Kind of exercise in the sense of kind of trying to get the machine to write something about an experience you've had, or try to evoke something that you think would be unexpected. I still think it's a worthwhile thing about kind of sitting down and sometimes playing with the technology to see what it can or can't do. Very quickly, of course, we realize that it's extremely limited in many ways, but we also know that there's a lot of, but there can be a lot of possibilities, and part of that, of course, is about how we use it and how we train it, and of course, who's building it and what their interests are, which is a big feature of this. And I guess in that sense, I had these images that, one of the things I had you guys read the Society of Control. So one of the things that we're really interested in. So here's the all glass store for Apple. So and it's kind of fascinating to see the old buildings and the sort of disappearance. And of course, by now, right, the world is about computing. But I also increasingly am really interested in the way that there's, we also have to always be interested in how ideas of the machine, ideas of the human feed back into each other, and then also how we are actually making ourselves in relation to our technology. So we're both shaping the technology with our speech, with our actions, but as all these quantified self technologies demonstrate, I don't know how familiar you guys are, but I mean, I told you, like, at first my sister gave me this stupid watch, and now I just can't stop counting my stupid steps and, like, how much I had a really, I tell this story often, but I had a really touching moment in a course in Canada where apparently I don't know, adults in my class, you look young to me, were in love and had synced their phones, had synced their watches so they could share heartbeats. But then they broke up and couldn't unsync. So I always was wondering what that means. But in the meantime, of course, Apple is getting all of that information. Yeah. So irrespective whether how close or intimate you are, somebody is tracking your data. But it also is really interesting question about how all these people were syncing their bodies to each other through the technology, and also how that formulates themselves, right? So now I really am constantly have I walked my 10,000 steps today? And am I healthy enough? Am I whatever? I can redo my whole body. And of course, there's many good things. There'd be a lot of medicine and care, especially with an older population. But obviously, there's also a vast amount of surveillance and consumption and other things that are coming in through these devices. But,
maybe this is a somewhat random talking point, but looking at this glass building from Apple, I was wondering whether you maybe see, because I gather this is somehow your field as well. Architecture. Somewhat of an communication backlash where people try to avoid communicating, because I was raised in an old building which has very separate rooms. You didn't hear a thing. We could live by each other in this house and not realize who is at home and who is not. And friends of mine lived in modern buildings with those open living spaces where you always, now I would say, communicate with everyone else in the house, because you
you're always forced. You're constantly.
And I hate that. I hate that a lot. I love living and having my secluded space where I don't have to communicate. And talking
on Instagram from your room to each other.
Well, yeah. No, but there are also people who stop to take those social media breaks. Isn't that also some? Can we integrate that into the same phenomenon? Maybe that's my question. And that is something that is happening despite corporations still being on this communicate more and share more trend.
Well, for starters, let's just talk. I mean, they've corporatized even our desire to withdraw. So mindfulness, yoga, meditation, all of these practices that we now try to exclude data and put ourselves in. Actually, in the 60s also coming out of, this is these are flotation tanks, and this idea of like media kind of isolation or Zen rooms. That actually emerging out of research, some of my research is on this because I'm really interested on the relationship between how we think about the brain and the mind and psychology and technology. People were actually developing historically after a lot of research into like soft torture and sensory deprivation and trauma. People were actually trying to develop methods for people to actually cultivate that. So there's a really interesting history about both how we've tried to exclude data and mindfulness and care of the self in relationship to also this idea of media inundation. And interestingly enough, one of the things they first discovered actually in the military is they discovered that radar operators, like all the guys sitting at these desks, were really were going crazy. Like they were having a lot of depressive breakdowns. Like it turns out that people working in these incredibly media-filled environments are also really struggle. Like too much media can be like too little. It can make people exceedingly bored, anxious, depressed, like when they're sitting at monitors all the time. And so the first place where this started to develop as a real issue was actually in the military, where they were trying to be like, oh, maybe we need to train people like through mindfulness, yoga, other things to be able to sustain overly informatic environments. So that issue you have between the open plane workroom, the hyper surveillant home, all this stuff has I think a pretty long, interesting history with also us needing our privacy. Sometimes, like, so it's been like quite psychologically developed that people do have these problems. And actually after COVID, apparently there's been a backlash to the open plane house. Like suddenly people are like, I want my room, I don't want to be here. I can't sit in the same, you know, I don't want to see you all the time. I don't know what that says. The American household has grown very big, actually. At least in America, people are buying bigger and bigger homes.
Yeah. Germany too.
Yeah. People are just like, that's it, I can't take you anymore. And also maybe because people are working at home also more and more. So suddenly it's there's not like I'm leaving anymore anywhere. But it's a super great question. That's sort of how we're dealing with it. I have other fun things I can keep going. You know, I have a whole bag.
We have only 9 minutes to go.
10 minutes. Okay.
Yeah. So do you have any? Yeah, I have to take the stream private because you're showing so much material.
Oh, sorry. Oh, okay.
Okay. So, but you will get the link to it. Do you have other questions at the moment?
Yeah.
I'm currently working at the theater, at the Students' Theater, and we have since like 1 year now the audio description available for people who can't see properly or can't see it at all, to describe them what's going on stage. So they get like a little headset, and then a 2-person team is sitting there and describing what is going on stage. It is fun to test, even if you see. But my question is, what do you think? How long could it take to like automate like this procedure to have a, I don't know, program seeing what is going on and describing that? Because that's a very difficult task, I think, even for seeing persons to also decide what is important to say, because the actors and actresses are speaking themselves. So you have a very little amount of time to describe the rest.
Mm-hmm.
And it would be, I think, possible, but very hard to train, for instance, AI to do that.
Yeah, I mean, this is really, Alexander, you probably know better than me, but this is actually,
No way.
No way, not anytime soon. But
one thing we at the moment we talk with the Bauhaus Weimar about a digital companion of don't know the word Gebärdendolmetschen English, sign language. Yeah, sign language. To bring all types of speech to movement. Yeah. And that's the first step. And if you have a computer model of certain kind of movements before any, in front of any background, then maybe you can describe, you can train an AI to describe what it sees. Yeah. Because you have data points, and that's maybe a possibility in 4 or 5 years.
So interestingly enough, so one of the things, so there's in the history, so there's I have other slides, Hebbian networks.
Yeah.
I'm trying to see if there's maybe just I'll show you an image of his experiment. Experiment. Okay. So interesting enough, one of the places. So this is a kind of problematic but super interesting history that I can come back and give another talk on if we want. So I don't know if we see any pictures. It's really small. Sorry. You might see a person here so this is a very, very famous study that came from the 1950s by a guy called Donald O. Hebb. And one of the interesting things is the model of the neural network. You've heard of neural networks, maybe deep learning, things like that, actually did come from machines that came from psychology. Cybernetically oriented psychologist, one of the most important, called Donald Hebb, was working with injured soldiers and people coming back from World War II, and started to notice that when you lost your vision, or you lost your hearing, or you lost a limb, that your brain might rewire. Mm-hmm. That there's neuroplasticity, what he was calling. And he came up with a very famous term that cells, which is to say neurons that wire together, fire together. What does that mean? Okay, here's a little baby example, but it's pretty much how the machines work too. Let's say, I don't tell baby what a cat is. A baby sees a cat, sees a lot of cats, maybe hears the word cat too. The more the baby sees a cat, the more certain neurons fire. I don't remember every cat I've seen. I don't remember every face I've seen. What I remember is when I see a certain set of stimuli, somehow my brain, a certain set of neurons trigger together. The more they're trained, which is to say the more faces they've seen, the more likely they are to fire together. Now, if that sounds familiar, that's how machines learn too, right? The more likely they're adjusted to a certain number of stimuli, and when those parameters are met, the more likely the net is being trained every time it sees a certain set of things to fire. But it really came from people. And once Hebb realized this is actually an experiment that was funded by the U.S. Military around the question. It's just a fact.
Every time.
Right. Well,
That's okay.
But that's it. It doesn't necessarily mean it's a bad experiment, because honestly, everything was funded by the military between 1945. Like when Sputnik, especially after 1956, when Sputnik went up, the Americans went insane, and actually in a great move for America, they went ahead and spent. Like if you said you're writing a English dissertation that will somehow show how literature is important for you. Everything got funded. That's it. They were just like, that's it. We're funding it all. And it was a very rich country, and so they could just fund it all. And personally, let's go back to that model. I think things went. Look how much stuff that happened. Anyway, not all. But he actually was trying to figure out how these radar operators were getting depressed. They wanted to find out about people who are in these information-rich environments, and they decided that too much information was like too little. And so he tried to have people lie, and their eyes were blacked out, like they couldn't feel anything. You just lay in bed, and supposedly all your senses were blocked out, except that every once in a while you were fed subliminal messages, like about ghosts or whatever. And people came out of this, everyone was like, and they paid a lot of money. And so all these grad students were like, that's it, I'm going to lie in bed for a month, and I'm like going to be rich forever, and I'm going to go on vacation. No one lasted more than 4 days. Everyone went totally ballistically insane. They came out, they had hallucinations, they believed in God, they believed all the subliminal messages. And basically people were like, oh, it's amazing. You can actually rewire people's brains through modulating the environment. But the up and down of this is that it both cultivated things like soft torture, but it also developed a whole idea that actually maybe we could switch, like we could, and also Norbert Wiener worked on this, like that you could maybe you could retrain the brain, for example, to feel something instead of see it, right, or hear it, right, like this is what you're talking about. And for the person, that experience would be meaningful. That I could train you to feel something, or I can rewire. And then the Neuralink also works on these principles that, like, maybe we could, if people lost their vision but saw at one point, so there is some training in the brain, we could reactivate those image loci or whatever directly. So these are powerful ideas that have a strong history, actually, and this was kind of also the start of contemporary neurosciences that we're still working on in many ways. That the human side is way behind the computer side in a certain way, but are super interesting. I'm super fascinated by this history.
So that's it. Thanks a lot.
Thank you.